Welcome to my new video. This is P. Indira Rajalakshmi, Senior Lecturer in Chemistry, Department of Technical Education. So we have started the chapter Fundamentals of Chemistry. In the previous two videos, we have seen some of these topics. So atomic number, mass number, Bohr atomic model, then distinguish between the electronic configuration, the principles of the electronic configuration. Now, from in today's video, we are going to see the remaining topics of this chapter. So let us go to the slideshow here and then we'll move. All these topics we have covered. So in the last video. So from here we will start. Orbit. What is an orbit? An orbit is the fixed path along with electrons revolve around the nucleus of the atom. Thus, all atoms particularly revolve in an orbit. So, according to Niels Bohr, around the nucleus there are the concentric rings in which the electrons are revolving. So, these rings he named them as 1, 2, 3, 4, 5 or KLMNO. And we know that the energy of the each orbit or shell is fixed or quantized. That's why he is calling them as the energy levels. Okay. So as we move away from the nucleus, the size and also the energy of the each shell or each orbit will increase. So in our previous video, I have given an example that when you cut an onion horizontally, so when we observe that in the middle, the center of the peels are very small, but as we move away from the center, the size of the peel goes on increases. So in the same manner, as we move away from the nucleus, the size of the orbit goes on increases as well as the energy also. Okay, so this is about the orbit. Now we'll see what is the orbital. So in the orbit there will be the subshells. So what is orbital? Let us see. The region of the space around the nucleus where the probability of finding an electron is maximum is known as the orbital. So here we are using the word probability. That is, we cannot say exactly where the electron is located in the orbital. The reason is that the electron is very light particle, so it is lighter than the light particle. So to locate its position, if you pass on the light, it will move away from that particular place. Thus, it is not exactly known the location of the electron in an orbital. So that's why we are using the word probability. Maybe, most probably, we will find the electron here. Okay? And it is the region of space. In a big space, there is a small region where the probability of finding the electron is maximum. That is known as the orbital. Okay? So we have S, P, D, and F orbitals. So let's move to the next slide. The shapes of the orbitals. Let us start with the first one, S orbital. So here it is visible that S orbital is spherical in shape. That means it is non-directional. Because it is spherical, it is non-directional and it is a spherically symmetric around the nucleus of the atom, like a hollow ball made of rather fluffy material with the nucleus at its center. As the energy level increases, the electrons are located further from the nucleus, so the orbital get bigger. That means, say the first 1s is closer to the nucleus, so it is smaller in size, and 2s is in the second orbit, so it is little bit bigger. Then 3s is far away, so here still bigger. So as the energy level increases, the electrons located farther from the nucleus, so the orbits get bigger. So the order in the size is like this. So 3s is bigger one and 1s is the smaller one. The So not only the size, but also the energy goes on increases as we move away from the nucleus. Okay, that means the energy of the 3s and also the size of the 3s is more than that of the 1s. Okay, now we'll move to the second orbital, that is p orbital. The p orbital, here it is visible that the shape is dumbbell, and then here each orbital is having the two lobes and the middle is the nodal plane, and then the p orbitals are oriented in three directions. The one which is oriented in the x direction is px, the one which is oriented in y is py, and the one which is oriented in z direction is pz orbital. Okay. So the p orbital is a dumbbell shaped or lobed region where the electrons can be found within a certain degree of probability. The node of the dumbbell occur at the center of the orbital where the probability of finding the electron is very low. Here the probability of finding the electron is very low. The shape of the orbital depends upon the magnetic quantum number associated with an energy state. So we know that for p orbital L is equal to 1. So the m goes like this. The m value depends on L value like this. It moves from minus L to plus L through 0. Okay. So if you see the m value, it is minus 1, 0, plus 1. That means total 3 orbitals are there. 3 orientations are there. So the electrons in the p orbital has equal probability of being either half. So here there are two halves. So there is the equal probability for the electrons to be in the either half, either this half or other half. And as usual, as just like s orbital, here also the p orbital's size as well as the energy goes on increases as we move away from the nucleus. Okay. Now next orbital is the d orbital. So here it is seen that the d orbital is having the double dumbbell shape. That means there are two lobes or four lobes. Then so the shape is double dumbbell. The third level there is a set of 5d orbitals. So total there are five d orbitals because the L value for d is 2. So m value is minus 2, minus 1, 0, plus 1, plus 2. That means total 5. Total 5 are degenerated orbitals are there. So degenerated orbitals are the orbitals which are having the same energy. So like as 3s and 3p orbitals, thus at the third level means that n is equal to 3, that is in the third shell. There are total 9 orbitals. So in the first level, there is only one orbital, that is s. In the second level, there are two s and p, whereas in the third level, there are three s, p, and d. Okay, so 1s, 3p, and 5d. That is total 9 orbitals will be there, and each orbital can accommodate 2 electrons. That's the reason the total of 18 electrons it can accommodate in those 9 orbitals. So if you observe this d orbitals, this one dxy, dyz, and xz, these three are almost looking alike. That means these three comes under one set and the remaining two comes under the another set. Sorry. So the these three orbitals, the lobes are oriented between the axes, whereas these two orbitals, that is dzx and dx x square y square, the lobes are along the axis. Okay, that is the difference. That's why d orbitals are divided into two sets. Okay, and then the d orbital, the lobes lie in xy, yz, and zx plane. That is in the first set, and in the dx square y square orbital, there are also four lobes, but whose two axes coincides with the x and the y axis. Okay. Now, coming to the dz square orbital, the fifth orbital, it has two lobes on the z axis and a ring in the xy plane. So this is somehow looking totally different, where we can find a ring in the z axis. Okay, so this is about the d orbital. D orbital is double dumbbell shape, so L value is 2, that's why the M value is 5 minus 2 minus 1, 0 plus 1 plus 2, total 5. That's why there are 5 degenerated d orbitals. Out of 5, there are 2 sets. One set, the lobes are oriented between the axis, and in another set, the lobes are along the axis. Okay, this is about the d orbital. Okay, now let us see the difference between the orbit and the orbital. So, orbit is the one which is the circular path around the nucleus. These are the concentric rings in which the electrons revolve. So, these are introduced by the Niels Bohr, and these are nothing but the principal quantum numbers. Okay, so he named them as 1, 2, 3, 4, 5. So, whereas the orbitals are the region of the space around the nucleus where electron is most likely to be found. The probability of finding the electron is maximum. Okay, then the second point, it represents the plane motion of an electron. And here it is a plane motion means, planar motion means, we can represent this on the two dimensional, we can write it on the blackboard, two dimensional structure, whereas here they are three dimensional structures. They represents the three dimensional structures where the electrons are found around the nucleus. Then the maximum number of the electrons in an orbit is given by the formula 2n square, where n is the principal quantum number. Okay. So, say for example, the first one, where n is equal to 1, the number of electrons are 2 into 1 square, and second one 2 into 2 square, then 3 into 3 square, likewise. So, see here, the first one only s in the k shell, there is only one subshell, that is S, that is 2 electrons. And in the second one, S and P, that is 2 plus 6, total 8 electrons. And in the third level, S, P, D, that is 2 plus 6 plus 10, total 18 electrons. And in the N shell, there are 4, S, P, D, and F. That means 2 plus 6 plus 10 plus 14. So, total of 32. Okay. So, whereas here each orbital can accommodate only 2 electrons. Okay. So, that's what we learn in the spin quantum number. In the spin quantum number, each orbital is can accommodate only 2, one rotating in the clockwise direction, another rotating in the anti-clockwise direction, represented by up arrow and the low arrow. Okay. Now, we'll move to the next point. The orbit is a circular in shape. Okay, whereas here orbitals are having the different shapes, like just now we have seen S is the spherical, then P is dumbbell, and D is the double dumbbell. Then next point, orbits are the non-directional in character, hence they cannot explain the shape of the molecules. Okay? Whereas here the orbitals are the directional, they are oriented in the different directions. So they can hence they can account for shape of the molecules. Then last point, the concept of the orbital is in accordance with the Heisenberg's uncertainty principle. Okay, so according to Heisenberg uncertainty principle, the electron is of a wave nature. So here we are the electron is of the wave nature only, that is in accordance with this rule principle. Whereas here the electron, the Niels Bohr, he treated the electron as a particle. Okay, so that's why he's saying that the electron will jump from one orbit to another orbit. Likewise, he explained. So the concept of Heisenberg is not, it's against here in case of the orbit, whereas in case of orbital the Heisenberg principle is in accordance. Okay, so these are the differences between the orbit and the orbital. Now we'll move to the next slide. So now, how to write the electronic configuration of the elements up to atomic number 30. So in the previous video clips, we have seen how to write the electronic configuration. Yeah. What is electronic configuration? So just till now we have seen there are so many, there are shells, and in which there are subshells, and in which there are different orbitals. Okay, and in those orbitals the electrons will locate. Okay, and now the question is how these electrons are arranged in those orbitals. Okay, that is called the electronic configuration. Okay, the arrangement of the electrons in the various orbitals is known as the electronic configuration. So we can write either in the NLX method or in the box method. NLX method, where N is the principal quarter number, L is the azimuthal quarter number, X are the number of the electrons. And then the box method, we will draw a box and we'll indicate the number of the electrons by arrows. Okay, so let us write the configuration using this method, NLX method. Okay, so we'll move to previous, and then while writing the configuration, we should follow the principles. Compulsory, we should follow Aufbau principle, Hund's rule, and Pauli exclusive principle. Okay, then we know that the Aufbau principle says that the electrons will enter into the orbitals in the increasing order of their energies, and the energy of an orbital is given by the value n plus L. That means the electron, while writing the configuration, we should write in such a way that first the electron should enter into the lowest energy orbital. Okay, so if for any two electrons, if n plus L value is same, then the electron will enter into the orbital whose n value is less. Then second rule is Hund's rule. This deals with the pairing of the electrons. So this rule says that the pairing up of the electron takes place only when all the orbitals are filled with the single electron. Then Pauli principle says that for any two electrons, all four quantum numbers will not be same. So while writing the electronic configuration, we should follow all these rules. Okay, so let us start from here. So these are the rows. So first row indicates the atomic number and the symbol of the element, then name of the element, and then this is the first shell, that is K, n is equal to 1. So we know that n is equal to 1, there is only one orbital, that is s orbital. Okay, and then in the second shell L, there are two subshells, that is S and P. So this row is S and this row is P. And then in the third level, that is M, there will be three subshells, S, P and D. So this is for S, P and D. And then in the N shell, there are four subshells, S, P, D and F. Okay. So let us start with the simple one, the hydrogen. Atomic number 1, symbol is H, hydrogen. Then here first only one electron is there. Atomic number 1 means only one electron is there. So very first shell is K shell, that is 1. This is the principal quantum number 1. And yes, then and in that yes, the electron is there, 1s1. Okay. So this one X indicates the number of electrons. Then next helium 2. 1s2. So with this 1s2 is filled up. So coming to the next element where the atomic number is more than 2, it will go to the next shell, that is L shell. Okay. So from the lithium it goes to next shell. So here we should put 2s1 and then 2s2. Okay. So likewise we should write. So in this slide we have given the electronic configuration of elements up to 15, that is phosphorus. The next page we have electron configuration starting from sulfur to zinc. Okay. So this is how the electron configuration should be written. And then here two things we should remember. So there is an anomaly in the electronic configuration of two elements. That is, one is chromium and the other one is the copper. Chromium atomic number 24 and copper atomic number 29. So why there is the anomaly in the configuration is the half-filled state and full-filled state. Half-filled means the d orbital, there are total, it can accommodate 10 electrons. So half means 5 electrons. So if there are 5 electrons in the d orbital, it is called the half-filled state. And similarly, if there are 10 electrons in the d orbital, d10, it is the full-filled state. Okay, so these two states are the stable states. Okay, so let us see the configuration of chromium. Chromium atomic number 24, chromium. See, while writing the configuration 1s2, 2s2, 2p, 2p6, 3s2, 3p6, 3d5, 4s1. So actually what we'll expect? 4s2, 3d4. That's what we'll expect. But here actually it is 4s1, 3d5. The reason is that there is rearrangement of the electrons in these two 3D and 4s. That means one electron has been shifted to here. Okay. In spite of 4s2 3d4, it is 4s1 3d5 because the 3d5 is the stable state. It will attain this type of configuration. Okay. Then similarly coming to the copper. Copper atomic number 29. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. So actually what we expect, it is 4s2, 3d9. But 3d and 4s electrons, they rearrange between them and the one electron will be shifted to here, making it as 3d10, 4s1. Okay. So because to attain the stability of the atom. Okay. So these are the two exemptional configurations, chromium 24 and copper 29. Okay. Okay, then now we came to know how to write the electronic configuration. So while writing the electronic configuration, we should follow the Pauli exclusive principle, Hund's rule, and Aufbau principle. Okay, all these three principles we should follow. And here the stability of the atom, half filled and full filled. Okay, so every time while writing the electron, by checking all these principles, it is difficult. So a simple method diagram known as the Euler diagram. This is a Euler diagram. So it has been introduced to write the electronic configuration very easily of any element with a bigger atomic number. Okay, so we can write the configuration of any big atomic number like this. So here the arrow shows the flow like this. The configuration will move. Say here 1s, 1s, and after that 2s. Then after that 2p, 3s, and after that 2p, 3p, 4s, and after that 3d. See here also you can observe. So actually after 3p, after 3p here, Yeah. 3p, what will expect? 3d will expect. 3p, 3d. So that the third shell will be completed totally. But what's happening? After 3p, the next electron is entering into the 4s. The reason is that the n plus L value for 3p is 3 plus 2, that is equal to 5. Whereas here the n plus L value is 4 plus 0, that is equal to 4. So 4 is lesser number. So first we have compared these two, no? 4s and 3d. So the n plus L value for 4s is 4 plus 0, that is equal to 4. And n plus L value for 3d is 3 plus 2, that is equal to 5. Okay. So 4s is having the lesser n plus L value. So first the electron enters into the 4s and then to the 3d. Okay. So after 3d, 4p, 5s, and then 4d, 5p, 6s, and then 4f, 5d, 6p, 7s, and then 5f, 6d, 7p, 8s. Okay. So this is the easier way of writing the electronic configuration of element of any big number using this Euler diagram. Okay. So with this, we have completed this chapter, and very quickly I am going to revise these topics what we have covered in this chapter. So very quickly we'll start from the beginning. Yeah, in the previous video, yeah, we have started from here. We have started from the electronic configuration. Yeah, electronic configuration, the arrangement of the electrons in the various orbitals of atom. And then here we have chosen, we have two methods, NLX method and box method. We have chosen the NLX method while writing the electronic configuration. Then this is the box method. And while writing the electron configuration, we should follow the three principles: Aufbau principle, Hund's rule, and Pauli exclusive principle. Aufbau principle says that the electron will enter into the orbital whose energy level is less. That means whose n plus L value is less. For any two electrons, if the n plus L value is same, the electron will enter into the orbital whose n value is less. Hund's rule deals with the pairing up of the electrons. The pairing up of the electrons in the degenerated orbitals takes place only when all the orbitals are filled with the single electron. Pauli exclusive principle. This principle says that no two electrons will have all the quantum numbers same. Then orbit. Orbit is the concentric ring around the nucleus where the electrons will revolve. Then there are number of orbits around the nucleus. Then as we move away from the nucleus, the size as well as the energy of the each orbit increases. And the size of the each orbit is quantized. Sorry, the energy of the each orbit is quantized, and also the angular momentum. Then orbital, it is the probability of, it's the region of space around the nucleus where probability of finding the electron is maximum. So these are the shapes of the orbitals. Let us start with the s orbital. It is the spherical in shape, non-directional, and as we move away from the nucleus, the size of the orbitals, s orbitals, goes on increases, and also the energy. Then p orbital is the dumbbell shape. It has two lobes, and there is a nodal place where the probability of finding the electrons are equal in these two lobes. In any lobe, we can find the electron. The probability is equal. And then based on their orientation, that is m value, a magnetic quantum number value, which is -1, 0, +1, that is total of 3. The p orbital is divided into three degenerated orbitals oriented in different directions. The one which is oriented in the x direction is px, the one which is oriented in y direction is py, and the one which is oriented in z direction is pz. Then coming to the d orbital, it is double dumbbell. It will have 4 lobes, and then the d orbitals are divided into 2 sets. So total orbitals are 5 because the L value is 2. So M value is -2, -1, 0, +1, +2, total 5. And out of these 5, these 5 are divided into 2 sets. So one set is this dxy, dyz, and dxz, and these are oriented between the axis, and the remaining one, the second set, is x square y square and dz square. So these are along the axis, the lobes are along the axis. The difference between the orbit and the orbital: orbit is a concentric ring or circular path, whereas it is the region of space around which the probability of finding electron is maximum. Then it is the planar motion of electron. It indicates the planar motion because it is a concentric closed ring, whereas here it is a three-dimensional motion of the electron because the structures are three-dimensional structures. The maximum number of electrons in each orbit is 2n square. So first one 2 electrons, then 8 electrons, 18 electrons, and totally finally 32 electrons. So where n indicates the principal quantum number, whereas here each orbital can accommodate only 2 electrons. Here the shape is circular. Here it will have different shapes like spherical, dumbbell, and double dumbbell. And then they are non-directional, hence they cannot explain the shape of the molecules, whereas orbitals are directional, so they explains the shapes of the molecules. Then the concept of Heisenberg uncertainty principle is in accordance in case of orbital, but here it is against in case of orbit, because in an orbital the electron is assumed to be a wave nature. Then how to write the electronic configuration? While writing the electron configuration, we should follow all the 3 principles. Then this chart indicates the electronic configuration starting from hydrogen to phosphorus 15. The first row indicates the atomic number, second one symbol, then name of the element, and then these are the shells. K will have only S, L will have S and P, M will have S, P, D, N will have S, P, D, and F. So likewise the remaining starting from sulfur to zinc. So in that manner we should write, and 2 elements shows the anomalous in the configuration. Those are chromium 24 and copper 29. So the reason is that to attain the stability, the half-filled and full-filled states of the d orbitals are stable states. So to attain the stability, the last 2 electrons, the electrons that are present in the 3d and 4s, they will get rearranged to get the stability. Okay, so the chromium half filled, and for copper it is full filled state. Okay. Then to write the electronic configuration, the easiest way is following the Euler's diagram. So this diagram, we can, using this diagram, we can write the electronic configuration of any element with bigger atomic number. Okay. So with this, we have completed these chapters, these topics of the first chapter, fundamentals of chemistry. So second part, that is chemical bonding, which is also included in the first chapter. We will continue it in the next video. Okay. Thanks for watching.